This one coding practice that seems counterintuitive at first can help you write 10 times better code. It has been proposed since 1970s and 1980s and has been practiced since 1990s. And I'm presenting it to you today because it still holds and it's important more than ever. This practice is called test-driven development, and I will tell you all about it in this video. Before I explain to you what is it and how to apply it, we should answer the more important question. Why? Why do we need such a practice, and what was the need that pushed developers to come up with such a thing? The truth is, when building software, no one completely understands everything and has the whole thing figured out. I'm talking about both developers and business people involved in the project. Developers are never 100% sure about the technologies they use, and business people are never 100% sure they are building what the client actually needs. And what does that mean? It means two things. Developers need a safe way to make sure they are using their tech stack correctly, and business people need a way to make sure clients need what they are building. If we were to summarize all of that in one word, we all need feedback. We need it as early as we can and as precise as it could be. The first intuitive solution is to just write tests for your code. Write a lot of them and at different levels. However, the better solution that might seem counterintuitive is to write tests, then start writing your code. Why is that better? And why can't you just write tests after you finish your code? Well, for several reasons. The most important ones are, by the time you finish writing the code, you might have designed it in a way that doesn't allow testing anymore. Starting with the test forces you to write testable code. Number two, writing tests first forces you to think about the expected behavior of your code before diving into implementation. This leads to better design and fewer unnecessary features. This will help you write enough code to make it work as expected without gold plating. Now you are convinced TDD works better. What is it really, and how can you start applying it today? The process is very simple. When you're trying to implement a feature next time, start with writing a test of what you expect your code to do as a first step. This test should obviously fail because you don't have any implementation yet, and that's fine. That's what we want. We want to start by specifying the behavior our code should follow. The next step is writing enough code just to make this test pass. That's the important part. Only enough code to make the test pass. Don't get excited and implement the whole thing. It defies the purpose of TDD. The last step is refactoring your code to make it neater and better while making sure your test is still green and you haven't broken the behavior. Then you repeat by writing the next test, the implementation, and then refactoring. You keep doing that until you are sure your code has the whole behavior expected. To make sure you understand that perfectly, we will apply it together implementing the famous FizzBuzz algorithm using TDD. If you're not familiar with it, the task is simple. For multiples of 3, print fizz instead of the number. For multiples of 5, print buzz instead of the number. For numbers that are multiples of both 3 and 5, print fizzbuzz. Otherwise, print the number itself. We'll implement fizzbuzz step by step using test-driven development. While we're using Java here, the same approach applies to any programming language. We will start with an empty test class called fizzbuzzTest. The first test case we want to check is that when the number is not a multiple of 3 or 5, it should return the number itself. Although the class doesn't exist yet, that's fine. We use it the way we expect it to be, and we use the method we would like to create. For example, I'll use assert equals, and the expected value is a string 1, and I expect to have a class called fizzbuzz, and a static method on that class called getOutput that just takes an integer, such as 1. And I'll add 2 other assert equals for 2 and 4. Congrats, that's your first failing test. Even though we didn't run it, it's definitely a failing test, as it failed to even compile. Now to fix it, we should write enough code to make the compilation error go away. So we will create the class fizzbuzz and the static method getOutput, and I'll just make it return null for now. Now that the test compiles, we can try to run it. As you can see, it fails, because we return null. We will write enough code to make this test pass. So I'll just return string.value of number. Run the test again. Awesome, it is green now. In the TDD cycle, this is the time to refactor our code. However, we haven't written much here, so we can skip it for now. Next, I will add the second test case, which is should return fizz if multiple of 3. Assert equals a string fizz if I'm trying to invoke the method on 3, 6, or 9. It will definitely fail. I will add just enough code to make it work. So here I'll check if number modulo 3 is equal to 0, and I'll return fizz. Otherwise, I'll return string.value of number. Next test case is should return buzz if multiple of 5. We will adapt the fizzBuzz class now by checking if number modulo 5 equal 0, then I return buzz. If it is both multiple of 3 and 5, I will write the test should return fizzBuzz if multiple of 3 and 5, trying it on 15 and 30. Now let's say I added the implementation like this. If number modulo 3 equal 0 and number modulo 5 equal 0, return fizzBuzz, and I placed it here. My tests will protect me from making such a mistake because numbers that are both multiples of 3 and 5 will be called by the first if statement here and return fizz instead of fizzBuzz. Thus, we should put this if statement first. Now all my tests are green. An important step we haven't went over much here is the refactor step, so we will do it now. Since we have an extensive test suite, we are safe to refactor our code without breaking the expected behavior, and we are confident enough to do so. So I changed the implementation to use string builder, and if number modulo 3 is equal to 0, I'll append fizz. If the number is a multiple of 5, I'll add buzz, and then finally I'll check if result is empty, I'll return string.value of number, else I return the result.toString. Run all the tests again, all good, our code is ready now. If you are interested to learn more about this topic, subscribe to my channel as I like to share videos about architecture, testing, design, and modern best practices. This will help you know about great topics in the field and might hopefully ignite your curiosity in one of them and make you dive deep into it.